Hello everyone, welcome to my YouTube channel Tech Spot. This is me, HarishGoupale. So basically in today's video, we are going to discuss about RTL design implementation of an half adder. If I talk about adders, so basically it is used for the addition of two binary numbers. Also it is used for sign and unsigned addition operation. If I talk about half adder, so it has two inputs. It can be A and B, and two outputs, that is sum out and carry out. And we know very well that sum out always computes by using XOR gate and store the result of addition, and carry out always computes by using an AND gate and store the result of carry out. Now if I talk about truth table of half adder, so if A and B both are low, then sum out as well as carry out both are low. If A and B both are inverse, then sum out will be high and carry out will be low. If A and B both are high, then carry out will be high and sum out will be low. Now let's jump for the design implementation of half adder by using an Verilog on a Vivado tool. So here you can see on my screen, this is the Vivado tool, and I have already written RTL code for the design implementation of an half adder. So we'll go through each line of code. My module name is half adder. I am having two inputs AB and two outputs, that is sum out and carry out. And I have directly used here assign construct. I have assigned A XOR B to the sum out, A and B to the carry out. Okay, now if I click on the schematic, here you can see my sum out is calculated by using an XOR gate, and carry out is calculated by using an AND. Okay, for the verification of this half adder, I have written a simple TB to verify this half adder. So the TB code is here. You can see the module name is TB half adder. Here also I am having same inputs A and B, two outputs carry out and sum out. And this is the instantiation half adder, instance half adder, A dot B of B, sum out of sum out and carry out of carry out. Now inside the initial begin, I have given four combinations. Okay. Now if I click on this run simulation, as I have already run this, so here you can see when A and B both are low, then sum out as well as carry out are low as per the truth table. When A and B are inverse, when A is low, B is high. When A is high and B is low, so you can see sum out is high, carry out is low. Okay. When both A and B are high, then sum out is low and carry out is high. So as per the truth table, we got the output. So here I will stop the video. If you are new to this YouTube channel, then please subscribe to my YouTube channel, and if you are watching this video, then please click on the like button.